So, hello students, welcome to lecture 8. So, in the last class in lecture 7, we had discussed about the bipolar junction transistor, that is the BJT, its working principle, construction, as well as all the three configurations, that is the common base, common emitter, and common collector. We also discussed how the voltage sources are implemented in all these three configurations. Today in this lecture we shall be discussing about the transistors load line analysis. So here we go. Starting with transistor load line analysis. So by definition the load line analysis of transistor means for the given value of collector emitter voltage we find the value of collector current. So this can be done by analyzing the DC load line, which means here the DC load represents the desirable combinations of the collector current and the collector emitter voltage. It is drawn when no signal is given to the input. As you can see in the input section, there is no signal in the circuit diagram and the transistor becomes bias. Now considering a CE NPN transistor circuit as shown here, where no signal is applied to the input side, for this circuit the DC condition will obtain and the output characteristics of such a circuit is shown in the next figure. Here we could clearly analyze that the the DC load line curve is. The load line analysis can easily be obtained by determining the output characteristics of the load line analysis method. So here in this plot, by applying Kirchhoff's voltage law to the collector circuit, this circuit as we saw in this figure, we get these equations, that is VCC equals to VCE plus ICRC and where VCE equals to VCC minus ICRC, that is represented at equation 1. This equation shows that the VCC and RC are the constant values and it is the first degree equation which is represented by the straight line on the output characteristics. The straight line represented on this output characteristics. This load line is known as a DC load line. The input characteristics is used to determine the locus of VCE and IC point for the given value of RC. Now the end point of the line are located as: first, the collector emitter voltage VC is maximum when the collector current IC equals to 0. From the equation we get that VCE equals to VCC minus 0 into RC, where VCE equals to VCC. Now the first point A, where OA equals to VCC on the collector emitter voltage axis shown in the figure. Now in the second point, the collector current IC becomes maximum when the collector emitter voltage VCE equals to 0. Then the equation becomes 0 equals to VCC minus ICRC, where IC equals to VCC by RC. This gives the second point on the collector current axis as shown in the figure. Now by adding the points A, B, the DC load line is drawn. As you could see, this load line is drawn. The green one is the DC load line. With the help of the load line, any value of collector current can be determined. So this was the clear explanation of the DC load line or the transistor load line analysis. In previous lectures, we have discussed that biasing. What is biasing? In terms of a diode, biasing means applying a voltage source either in the positive or in the negative direction. But in terms of a circuit, biasing is the process of providing a DC voltage which helps in the functioning of the circuit. Now, The more concerned we are about here are introduction to the transistor biasing. So a transistor is based in order to make the emitter based junction forward biased and collector based junction reverse biased, so that it maintains an active region to work as an amplifier. So what is transistor biasing? So transistor biasing can be defined as the proper flow of zero signal collector current and the maintenance of proper collector emitter voltage during the passage of signal, which is known as transistor biasing. While the circuit which uh, gets it's the circuit which has a transistor in it and it gets biased by a voltage source, it is called as a biasing circuit. So what is the need of DC biasing? So if a signal of very small voltage is given to the input of BJT, it cannot be amplified, because for a BJT to amplify a signal, two common conditions have to be met. So what are those two common conditions? First, the input voltage, the Vi, as you could see here, should exceed the cut-in voltage for the transistor to be on. So this voltage Vi, if and only if exceeds the cut-in voltage for the transistor, then only the transistor gets on. Now moving on to the second point. The BJT should be in the active region to be operated as an amplifier. So inappropriate DC voltages and currents are given through BJT by external sources, so that BJT operates in active region and superimpose the AC signals to be amplified. Then this problem can be avoided. The given DC voltage and currents are so chosen that the transistor remains in active region for the entire input AC cycle. Hence, DC biasing is needed. This figure shows a transistor amplifier that is provided with DC biasing on both input as well as output circuits. So, we have discussed about the transistor biasing in brief. So in the next class, in lecture 9, we shall be discussing this transistor biasing in details. So guys, today in this lecture 8, we discussed about the DC load line analysis or the transistors load line analysis, and we discussed about the biasing of the transistor, biasing of the circuit. Though it was not enough, in the next lecture, in lecture 9, we'll be going deep into the transistors biasing methods, its the circuit, and as well as we'll do some multisim examples where we'll realize the simulation methods to analyze the biasing of the circuit or the transistor. And you guys had some issues regarding, I was having some issue regarding the audio part. I hope it has been improved and I have done some modifications. So if any other improvements can be made in this lecture series, please comment below. And if you find this video informative, please hit the like button. Comment below if you have any doubts and subscribe the channel to stay connected with us. Thank you.